Wonderful. So another news, I bought a bonsai tree and it is doing really well. I'm pretty proud of this. There you go. I'm absolutely chuffed with that. There you go. Put it there. So what's the plan today, folks? I'm going to get into the swing of things with a conversation following on what we had last week, but this time on a spin on that idea of cybersecurity. Now that we know presumably a little bit about how the internet works, and there's a window, there's a helicopter outside. So now that we know how the web is built up and how we can architect around this, I want to introduce, or reintroduce, shall I say, a subject of security within this new context. So we start with the beginning, and this is maybe a topic that might be new to some of you too, and I think probably a dedicated session is needed for this one alone, which is this idea of Git and GitHub. Now, I know that this is a little bit out there, but basically these are technologies that are out there that are used again by developers or programmers to, in effect, version control their software. Yeah, so that basically allows them to save code and throw that up somewhere safely to an internet-based repository, they call it. So in the case of a failure locally, if your laptop goes on fire, if whatever happens to your hard drive, you at least have a hard backup in place, okay? And that is somewhere up in the cloud. So you basically put your code into another place. And we call that thing a repository. But because code is always in flux and you're always making changes to them, you also need to keep track of the changes that you made to your code in order to possibly go back in time to a previous save state, like a checkpoint, shall we say, in case you produce a version of the code that is, in effect, broken. Wonderful. Oh, yeah, so Nick just pointed out that you are finishing or wrapping up the Python course. That's gone well. I haven't actually seen the latter half of that course. I did the first couple of weeks and I loved them. So that's wonderful. If now you're in the point of thinking about throwing your code up to another place or broadcasting it online, it has some great advantages to this. But I think, to play devil's advocate, it also has some potential disadvantages because of that very nature of this being a version control of this structure of you being able to go back in time. So imagine if what we have is a few initial commits, and that's the term of art here used by Git in order to throw your code into something. And a commit is really just GitHub parlance for a set of code that I'm sending off to the internet. I'm committing it over there. So I've decided to take file A and file B and file C in their current versions, and I've saved them with Control S or literally my machine. I want to send those versions up to GitHub to be stored permanently in the cloud, or semi-permanently, should we say. So we can package that up into something that's better known as a commit, and then push that code up to GitHub where it would then be visible online to myself or other teammates. Basically this would be packaged up as a commit. Welcome, Trudy. What we're thinking about is the cybersecurity topic of the web, and if you stay with me, I'm going to do some demos at the end. We're getting into grips with what it is to throw your code up online and what the disadvantages might be around that. So if you take something like GitHub, which is a place for you to take files and really just view them on GitHub as being tracked in terms of these commits, and again, commits will be chaining together. You'll see this idea of chaining in the past where we discussed like data type, linked lists, for example. So every commit knows about the one that came after it, okay, the one that eventually it's going to be pushed into, as well as the ones that preceded it also. So let's imagine a scenario where you have an initial commit, your first push, where you post some code onto the internet, and then you start to make some more changes. So then imagine we have, again, our initial commit, we post some code up, we make some more code, we write some more dev, we make some more changes, and then we perhaps update our database in such a way that when we post or when we push, shall we say, excuse me, our second commit to GitHub, we accidentally expose some of those credentials. We give something away. And perhaps someone inadvertently typed the password on how to access the database into some Python code that would then be used to access the database, perhaps. It's just not a good thing, okay? And perhaps anyone with the ear to the ground this last week has heard all about T, this social media website for gossip, which has become the latest in the series of credentials being leaked or misplaced. And maybe someone really quickly realized, hey, you know what? We need to get this stuff online. We need to take it off GitHub, perhaps, because that is a source repository and it's available online and it's perhaps not something you want to make publicly visible. So let's think then, okay, I just gave away my keys online. Let's make a third commit, a third push to GitHub that again scrubs off and deletes those credentials. So that's it's gonna store them somewhere else. That's not going to be saved on this particular repository, on this repo. But have we actually solved the problem? I mean, you can probably imagine that answer is going to be no, because we had this notion, we had this idea then of version control, where every past iteration, everything you've done before, all those files beforehand are still stored on GitHub, such as that if I really needed to, I could just go back in time. I could go to that last checkpoint, in effect. So even though I attempted to solve this problem, the security crisis, I just created for myself, by introducing a fourth and final commit, one that removes the credentials from those files at the end, such as if I'm looking for the most recent version of the files, sure, I don't see it anymore, I've kind of shaved off the last layer, but I still have the ability for me to go back in time. And that actually doesn't solve a problem. I've sort of poisoned the water now. See, one of the interesting things about Git and GitHub is the model that's used for it. Because at the very beginning of GitHub's existence, it relied pretty much exhaustively on this idea of, again, you sign up for free, it's a Microsoft product, you get a free account for GitHub, great, and you have a limited number of private repositories. I still think, well, it's a good business strategy, sure. Repos that are not publicly viewable or publicly searchable, let's say, and you could perhaps pay more if you wanted more to have that option. But the majority of your repositories, assuming that you didn't opt into the paid accounts, were free, which meant that anyone on the internet could search for them. Anyone could just do a quick Google search, or even like a GitHub search, and just use a regular expression just to look for something. And so if all of your GitHub repositories, like what happened with T this week, happen to match what that person was looking for specifically, or if you're looking within GitHub search feature, which is also really good, if you are using, if you're looking for specific lines of code, if you're looking for particularly dangerous characters within a public repository that is available, it could be found. So you're right, and that's perhaps the first thing to do. I just want to talk about T for a minute because it's let's talk about T. I don't know the app. I've never used it before. I've just heard about what's happened with the leak. Okay, I just want to find more of a technology focus, less on the kind of incels behind this. So hackers leak 13,000 user photos and IDs from their T app. We also know this is a particularly busy week in terms of ID verification. The UK has also passed the legislation in order to stop people gooning online. And there's ways around this. People always find exploits. But now this is a particularly damning problem that, well, the way that this happened was the person who made this app himself not being a developer and didn't come from this background. I think someone went through his LinkedIn post and realized, oh, this guy just did a 6-month bootcamp and that's it. And he just vibe coded the rest. That is to say, he took like an AI app, and again, I'll show you this later, but he basically just hallucinated an app which went virally sensational overnight, but made some pretty basic errors, things that you and I would know better. So she says, yeah, sure, can't you just make an S3 bucket private? Yeah, you can. That's the default behavior. In this case, they were using Supabase, which is Google's product for like a managed database online, and you have to go through a lot of options in Supabase in order to make it publicly accessible. That is, it starts off private. There's a lot of like UI interfaces. I think it was probably done on the page, which Supabase was. And again, and they take every single effort in order to tell you that this is going to happen. They'll send you emails. They'll kind of flash on screen, hey, this is made publicly available. So yeah, a lot of people were able to find basically driving license and photos and basically just a data leak that wasn't meant to be. And this is not hard to do if you make it public. So
sorry, Marco, can I just double check? Did you say T leak was a GitHub repository leak? Is that what it was?
It wasn't in that case a GitHub problem, but the idea is still the same. Well, I'm using the idea of credentials being leaked. When I read the PowerPoint was that, but that was like the news, right? It's just personally identifiable information. It's perhaps not as damning as actual keys or things that you can log in as, but still not something you want to give away. Who wants to be part of a data breach? So if you'll entertain me, let's go to Grey Hat Warfare. Because what we're describing here is essentially a leaky bucket. Yeah, something with perhaps some flaws in the design, not because the technology is flawed, but the person behind the wheel is. So we'll need to go to this kind of middle ground of Grey Hat Warfare, not good or bad, and search for, if you forgive me, I'll just type in, I'm going to search for Kashif.
Do my surname as well, Kashif Din. D-I-N.
You set me up, let's see. So this is, what I'm doing here is just a regular Google search, but in a lens that's going to index files buckets. So you're good, you're clean. Maybe there's actually more with a premium search, but okay, at least on that side we're fine. Maybe, this is perhaps germane to the keywords used. I don't think people are going to title themselves after the buckets, but perhaps using something like a file in such as this. So this guy, okay. Okay, it's not too revealing. I often go for something a bit more like, let's go for something like CV. It's often a better kind of catch-all, should we say? Now, actually, in the news example, that was more to do with driving licenses, I think. So someone, you're basically being asked to prove your identity with a government license. I'm not going to use doc types because, one, I don't trust it, and secondly, I'd rather have a PDF that I can trust a little bit better. So this is coming from a data blob, Azure data store. So Azure's version of S3, okay? So I know everything that I need to know about James Mullins. I know his phone number. I know what he likes. I know what he's done. I know what he's read, apparently. Oh, okay, so I was going to say, is he referencing his own TV? Turns out he's just a really smart person who's written a lot of stuff. Okay, but maybe you don't want to do this. Perhaps your CV is just a more obvious example, a more luring example. But you can well think of things like passwords or database or any kind of regular expressions which you would typically associate with a say passport, for example. .jpeg, let's say. Not jog. JPEG. Okay, I don't know what's going to come up, but you never know. So I think, without going into this too much, we'll find. What I'm doing here is nothing illegal. Okay, I'm just using Google like it's supposed to be done. Okay, so Mr. P. Rapong, who's Thai, was born in this blah blah blah, without that hard of a thing. So it's pretty similar to what you saw with the Online Safety Act that the UK is now pushing. Would you trust them to have your information stored in something that could potentially be made public or accessible online so easily in the case of T? What's more is once it's out there on the internet, it gets then maybe cached, we've seen, or stored copies of them live elsewhere. It also exists on many forms. People save that thing online. You'll find it in the Internet Archive, if you're familiar. So it's like the great Alexandria's worth of old websites, which perhaps don't exist anymore, but they've continued to be immortalized in this. So let's take, for example, AWS, which I'm going to find a console. AWS. What's the actual management console called? AWS.Amazon, okay. It actually works. I tried it the other day. It does go back to 2006, which is very impressive. Internet Archive. It's called the Wayback Machine.
When you say it goes back to 2006, you mean just the UI?
Well, as long as the APIs still match up, I didn't try to do anything, admittedly. It might just be read-only copies for sure. Back. Oh, come on. I thought this was going to be a lot quicker than it was. Sorry. Let's go forward one. So this is a great way. Again, researchers, or if you're ever doing like forensics and you need to prove something, old tweets, they get deleted. Well, people check the Wayback Machine to make sure that it was actually said at one point. So if you go back to AWS, for example, AWS.console, I think it was called.
Oh, Amazon console.
That's the one, yeah. Come on. It is a bit slow because it has to pull kind of those source files and then load a container in places. Okay. Okay, it's going to take a bit. The point being that, once you poison the waters, once you put your credentials out there, I was going to find one that works, so I'll just skip that. Well, let's go back to anything else. Let's go back to, let's go back to GitHub, because we just talked about GitHub. That probably goes so back to 2008, and you can see what the UI looks like and how actually it worked back then when it was just, nascent. It has recently now changed to a model where you now have, this is way too modern. So go back to 2009, perhaps, and I'll just pick a date from then. A great website, by the way. I love this place. It's a bit slow, obviously. It's not usable, kind of, for many reasons. But we'll get there eventually. That's what it used to look like. GitHub, social coding. Very, very, very distinct. Very different to what it is now. So then it was more about searching for public Git repositories, and you only had a select amount of private ones. And after you've kind of exhausted all your private ones, you had to then maybe put them public. I think that's the problem that came about with this. Same goes with S3. Like, you before wouldn't start with the default private behavior. They only then changed that after the fact because people were basically exposing themselves too easily. And it lives on for years to see. So nowadays there's a higher limit as to the amount of private repositories that someone could have. But this was very much the design early on to kind of get people, programmers, and sort of create this open source community where anyone could view anyone else's code. And so, well, back to this. I mean, in terms of GitHub's parlance, you fork someone else's code. Basically just means going and taking someone else's entire repository or collection of files and then copy that into your own repository to perhaps make a change or suggest an edit or push those changes back into the code base. The idea is trying to make the community as a whole better. A side effect, though, of course, is if the items, if your sensitive stuff gets revealed, then what we do, it's only because this public repository setup we have there is dangerous. So it's great in terms of the ability for you as a programmer to refer to materials on the internet, put them online. You don't have to just rely on your own local machines or your own hard drive to store code. It allows people to work from all over the world, similar to how Dropbox or Google Drive works, for example. You can just put it into the cloud and then access files from different machines from all over. You don't even have to be from a specific machine to access a file, as we used to have to do before cloud-based documents or S3 even existed. It encourages collaboration in that case. So, for example, if you and I were to collaborate on GitHub on a repo, I could push changes to that repo, and then you could pull them, and then we could be sort of working off the same code base again. And we sort of have this central repository, this central area where we could share our code with one another. And we can each individually make changes or incorporate each other's changes into our final products. So we're always working off the same base of material. But again, the side effect of that then is that this material is generally public, unless you have opted into private repositories where, again, you have specific individuals who are logged in with their own accounts who just want to share that. So, is there a way to solve this problem? We expose accidentally our credentials in our public repository. We put it out there for everyone to see, like raw materials. Yeah, like if we made that mistake, of course, like Ashish said, if we're working in a private repository, probably not as alarming because it's probably not something that it should not be encouraged to do or have credentials for anything anywhere. Whether public or private on the internet, it's just obviously a bit riskier. That goes without saying. But is there a way for you to get rid of this? Prevent this problem from ever happening? Fortunately, in 2025, there are a few different safeguards that are specific to Git and GitHub that we can use to prevent accidental leakage of information, so to speak. So, for example, one such way you can handle this is using a program or a utility called git-secrets. And git-secrets works by looking for a regular expression. And a regular expression, if you're familiar with git-secrets, or regex for short, it's just a computer science parlance of... So, it's a particular formatting of a string. So I'm looking for a certain number of characters, a certain number of digit characters, there's maybe some punctuation marks. And you can say, well, I'm defining this and I'm looking for strings that match this idea. And so you can express this idea, where this idea is all kind of capital letters or lowercase letters, as many numbers, as many punctuation marks, and so on, using a tool called a regular expression. So git-secrets contains a list of these regular expressions or these regex patterns, and will warn you of when you're about to make a commit, when you're about to push code onto GitHub and send it off to GitHub to be stored online, that you have a string rather that matches this pattern that you wanted me to warn you about, in fact. So again, just to be sure that you commit this code and push this code, that you actually intended it to send it up to GitHub, because it may be that this matches a particular password or something that you're trying to avoid. So that's an interesting tool that could be used for that. But that's not it, okay? There's others. You may also want to consider limiting third-party app access. So GitHub accounts are actually you know, when you can log in with Google, you can log in with Facebook, log in with GitHub, a very common use of identity providers do. So you can use as other forms of logins. For example, there's another form on the internet called OAuth, which allows you to use, for example, your Facebook account, your Google account, your Twitter account, or your Google account, you know, to log into other services. Maybe you've seen this yourself in your own kind of experience working in different services on the internet. For instead of you having to make a new account or making you login for XYZ, just use your Google account, use your Google login, or in many instances too, your GitHub login to do so. So when you do so, just be careful though, just because GitHub, you are then allowing a third-party application, again, so someone that's not GitHub, the ability then to use and access your GitHub's identity or your credentials. And so again, you should just be very, very careful with not only just GitHub, but other services as well, other identity subscribers, thinking about whether or not, which service you want to have access to, GitHub or Facebook or Google or any kind of information, let's say, even if it's just for use for authentication. So could be an idea to limit that amount of usage. Perhaps more interestingly is this other tool. So this is called a commit hook. And now, so a commit hook is just a fancy term for a short program or a short set of instructions that executes whenever a commit is pushed to GitHub. So for example, many of the course websites, you know, so many of the things that we see, like SharePoint included, is GitHub based, which means that when we want to change the content of the course website, if you wanted to update some HTML, if you wanted to update some backend files or whatever, you can push those up to GitHub, and that would trigger a commit hook, where basically that commit hook will copy those files into the web server, run some tests on them just to make sure that there's no errors with them, do a bit of debugging. So for example, if we set up a pipeline where you have some JavaScript code, some Python, and that was breaking, had a bug in there, something was problematic, we'd rather not deploy that bug, so to speak. Okay, we don't want the broken version of the code to replace the currently working version. And so that commit hook can be used for testing as well. And so if all is good and the test will pass, then we're able to activate the files, then we're able to put them on the web server and affect the changes that have happened. So again, yeah, so when we're using GitHub to store the changes that we want to make on our site, so the HTML, the Python, the changes that we want to make, and if we're using a commit hook, a set of instructions to copy them over and actually deploy those changes to the website once we're verified before breaking anything. You can also use them to check up on passwords. So you can have it to warn you if you perhaps again leaked a credential, and then you can undo that technique that we'll just see in a moment. Beyond that, there are other technologies that you will use, and we have already talked about, to encrypt communications. And this is a little bit more technical, perhaps used by programmers and sysadmins alike. There's a protocol that we know called SSH, or the secure shell. I'll type that out. This is a technology via which you don't necessarily encrypt all your traffic between points A and points B, although you can use SSH to create the equivalent of a VPN or a virtual private network. But again, SSH is all about connecting off from you to a remote server, to a faraway machine, and executing commands over there. So you're not executing commands on your own machine ultimately, but on some other machine that's maybe inside of a company or somewhere else in the world. So in our case, what we can do when we're using GitHub is actually protect or verify your identity with an SSH key. So keys, again, not physical, but they're a form of a public and a private key. And in this case, it's not really used for encryption, though it's actually used as authentication as well. So again, this idea of digital signatures, which we talked about before, comes back into play. So whenever I use an SSH key and I push my code up to GitHub, what really happens is I also digitally sign the commit that when I send it up to. And so before that commit gets posted up to GitHub, GitHub looks at the request coming through, it checks the public key and verifying, again, using mathematics that we've seen far too complicated today, but that yes, only Marco could have said this to me because only Marco's private key, his equivalent's private key, can unscramble the ones and the zeros that are needed, so that only he could have been created this. Only he would have that private key, so it must come from him. You know, those two things are sort of reciprocal of one another. And so we can also use SSH keys as a form of signature, signing, as a bit of identity verification scheme as well for GitHub, because we might use this for mailing documents or sending documents or something like that. And okay, so we've already posted the credentials though, like it's already out there accidentally, whether we like it or not. Is there a way to get rid of them? Well, GitHub does track our entire history, but what if we make a mistake? You know, we're humans, we're fallible, and so there is actually a way to eliminate the history, which is a command called git rebase. So just to go back to the illustration that we had a moment ago where we had several different commits, and I've added a fourth commit here just for the purpose of illustration. So the first commit and the second commit, and then it's after the second commit that we expose our credentials accidentally. So from that point onwards, then we have a fourth commit where we actually delete that mistake that we had previously made. So when we're using git rebase, the idea is that we want to delete a portion of the history. Yeah? So deleting a portion of the history has a side effect of any changes I made in the past here. Again, in the illustration here, we're just going to get rid of the past two commits. So any changes I made besides accidentally exposing the credentials are going to be destroyed. So it's going to be incumbent on us then to make a copy of this, to actually save the changes that we actually want to preserve in the first place. In case we do more than just expose credentials, and then of course we need to make a new commit, a fifth commit in this idea, in maybe a new history or a new repo, just to still preserve those changes that we're going to make. So let's say, other than credentials, I didn't really do anything else. one thing I could do is rebase or set a new start point essentially. The second commit is going to be the end of the chain. So going all the way through to here and then having that preserved ad infinitum. So I just want to get rid of everything from the second commit going forward. Again, I can do that. Again, those commits are no longer remembered by GitHub. It just essentially wipes its memory. So as soon as the next commit I have would go here, and then again right after the second commit, as opposed to imagining like a fifth one or a sixth one, right after credentials being removed, those commits are, these ones are for all intents and purposes just forgotten. They're gone. Oh, yeah, I guess one more thing. Good habits that we can get with GitHub as well. Just mandate the use of MFA. Recall we've probably discussed as well. Two-factor authentication or multi-factor authentication previously. The idea is that you have a backup mechanism to prevent unauthorized logins. And so they use two factors, the FA in 2FA, and not passwords necessarily, because again, they're fundamentally quite similar, passwords. The idea is that you want to have multiple factors, like something for example, the password, that's usually one of the more common ones in a 2FA, and something you have. So the thought of an adversary is, it's very unlikely that a bad actor would unlikely have both of those things at the same time. So they might know your password, okay, but they probably don't know your phone. They might not know your RSA key. They might have stolen your phone, but they might have stolen your key, but they probably don't know your password as well. We're just increasing the cost to them to know that, okay? And so obviously, this idea is that this provides us an additional layer of defense against potential hacking and to break into accounts, another layer of security on unauthorized behavior in accounts that you obviously didn't want to happen. So what's an RSA key? That is something like this. Again, there are different versions of them online, sort of evolved over time. This one's actually combined RSA with a USB as well. So inside of the window here is a 6-digit code, one that changes every 60 seconds or so. So when you give one of these, for example, perhaps at a business or a firm or just assigned to you specifically, there's usually some server, some machine somewhere that your IT team will have to set up. And that server will map the serial number that's on the back of this to that RSA key. So maybe, let's say that server now knows your employee ID, for example, and it kind of relates those two together. But otherwise, they don't know what the number currently displays on the RSA key. They know who owns it, who should be the proprietor of this, who's physically in possession of one, which employee ID it maps onto, because every 60 seconds, or I think whatever those denote here, it changes again according to some algorithm that's built into the key. It generates numbers in a pseudo-random way, and then after 60 seconds, that code will just be something completely different. You would then have to actually have the key on you in person to complete a login. So that's a multiple layer of security. If an RSA key is being used to secure you, that you need to either enter a password and your RSA value. You'd have to have both those things, a password and this. No other, goes without saying, obviously, you can't use someone else's key, okay? Well, there's like a corner case or hypothetically a 1 in a million chance that it might be randomly showing that same number at that same time. But again, no other employee's RSA, no one else's key and password would be able to log into you, okay? Only yours would be used to log in. Okay, no, there are actually a couple of tools out there that can be used to provide to FA. The USB stick was obviously quite an expensive solution, but there's no technical reason not to use them. Oops, I didn't mean to write over that. But the point is that you're going to find them for free on app stores, on Google Play stores, most likely. You'll find things like Google Authenticator, Authy, Duo Mobile. I don't know if it's just me, but I've been getting a lot of text from Microsoft Authenticator recently saying, I'm going to lose part of my autofill. Does anyone else use Microsoft Authenticator?
Yeah, I do.
Yeah. Are you getting notifications lists like 2 weeks ago about losing some features?
No,
Yeah.
No.
It was bugging me for ages. Yeah. It loses the autofill password this week. I don't actually know what that's about. As of today, it will be no longer possible to fill in passwords via this app. Okay. So that's not it losing your RSA key, but the fact that you can, when you submit a form field to a browser, perhaps, it won't prompt you unless you're using Edge, which is, again, another shady way of them encouraging you to use Microsoft products. I'm starting to realize Microsoft are a company that win, not because they're better, but because they outlast the competition. Like, here comes a new startup, they do a cool thing, a new idea, and they're flashy and they're greater than you. Microsoft will copy that model, worse admittedly, throw money at the problem in order to have their equivalent, and just, over the course of capital survive, they can absorb the damage. And that's how we end up with slop that Microsoft put out there. Anyway, so I think, well, that's one way around this. But others too. And also text message too. So if you don't want to use those specifically, you can also just use a text message from the service itself. Again, just to get this via SMS on your phone. It's all Pinpoint, by the way, on AWS. If you not that, it's going to come up very often. But there's a service that does this called Pinpoint. I know how to use it. You could do this yourself with Cognito or with SNS. Yeah, it's like SNS really. Again, but this is one of those really, really corner cases where you could do it one way. You could manually do this yourself. As in, you could set up the let me just do this. Again, multiple. Let me just sign in with you then. Bugger it. Swapping out a ringer for a ringer. Okay, we're in. No, it's blocked. Okay. It's in the other room. I don't want to do it. That's super annoying. Perhaps another the downwards pressure of this is it becomes more annoying to the to the hackers, to the adversary. But who does it also annoy? Me. So this is the feature that Microsoft Authenticator are apparently dropping. This way of storing passwords online. Multi-factor authentication. Sure, I might have forgotten my password, but chances are I still remember my key or my fob or my eyes or my something else. Something I am, something I know, something I have. So if we go back to Builder ID, this one now, that should now load. Sorry. Yes. Sign in. Log in. There you go, finally. So what was my point? Oh yeah, so pinpoint. I've only ever heard it as a as a distractor in certain questions in some exam papers that say, can I do it with SNS, like Trudy says, or can I do it with pinpoint? Usually pinpoint is the wrong answer. And actually will stop yeah. So apparently it's gonna go away forever. So forget about it. Yeah, they kill services if people aren't using them. So that's another example right there. Code commit is also one of those too. Because people just don't use it, in effect. People much prefer to use GitHub. That's what companies use and use. So again, code commit is no longer available. You can't use it. Yeah. Services are available all the time. So I mean, I could probably use these ones, but I don't think I can. Anyway, so the bottom line is use for what works for you. And some of these are just de facto things that there's no technical reason why you should avoid them, like 2FA. There is, again, that social friction I just showed you because I find it annoying. So it used to just be username and password, you logged in, that's it, pretty quick. Now it's username, password, go to another screen, enter a code here or some advanced application, you get push notification to your phone or your device and you have to then unlock that, press OK. And that's inconvenient. We haven't yet reached that point where actually 2FA is the norm, but it is getting there. So still kind of a linchpin when we talk about the security for the internet context, where often it's human beings, us, the chair, that are the limiting factor on how secure we can be. We have the technology. We know what steps are going to be good to protect ourselves, but it's long. Yeah, like Trudy says, I don't feel compelled to do so. And so we'll see this pattern emerge in a few other places today, where just that it's perhaps you're not seeing the adoption of IP version 6 or 2FA. It's not that it's technically infeasible to do so. It's just that we humans find it annoying to do so, or we're used to it. We like it the way that it is. So we just don't adopt it as aggressively as perhaps we should do. Okay. To discuss another kind of attack, another type of attack that does happen on the internet, where, with unfortunate regularity, this is the idea of a denial of service attack. Now, the idea of a denial, behind these attacks is basically just to cripple the infrastructure of a website. Now, there are many reasons behind this. Again, it might be financial on one side. You might want to try to sabotage someone. You know that your neighbors next door are kind of doing this website. There might be other motivations too, like a distraction, for example. You might want to tie up the resources just to try to stop this attack. That opens up another avenue to do something else, to perhaps steal information from them. There's a lot of different motivations behind why they want to do this. Some of it just for fun, boredom, should we say. Amateur hackers or script kiddies will just think it's fun to initiate a denial of service attack against an entity that is not prepared to handle it. But I guess I just want to take a bit of time just to talk about this in particular and draw your attention to some areas of concern, some areas that might lead to more discussion. And so those that were with me for the security engineering course will know I often go to this website, right here. Yeah. So with let me just paste it in the chat should you want to. This is actually a book that exists, but I'm relying on the website too. So I guess the biggest of these attacks, of which there are many, it tends not to be taken as seriously by people when you hear about them, because you'll occasionally hear these attacks in, again, the news. The denial of service attacks, or the CASM as well, the distributed denial of service attacks, where, again, culturally, us being humans, we're sort of neglecting some of the real security concerns here. We just don't think of it as attacks. And that's because maybe when we hear about other kind of attacks on the news are seen as more physically devastating, they have more real consequences, but it just makes it hard for us to have a conversation about cyber attacks, because there is that friction that we're trying to face of get people to understand that, these are meaningful, these are real. And in particular, these kind of attacks are insidious. They're really easy for you to execute them without much difficulty at all. Like, you can go and buy software, you can buy ransomware, you can buy attacks online, especially against small businesses that might be running its application, its own server, as opposed to relying everything on the cloud. So a pretty, top of the line, commercially available machine might be able to execute a denial of service or a DOS attack on its own, just by nothing else. It doesn't even require that expensive resources. But when you start to think about mid-sized companies or large companies or enterprises or entities, one single computer from one single IP address is not going to be enough. Okay, so instead you would have a distributed denial of service attack. In a distributed denial of service, there's still one hacker, there's still generally one bad motive. There's a person behind this, or a collected group of hackers or adversaries, but they're all trying to penetrate some companies' defenses, but they can't do it with their own machines. And so what they do is they'll create something called a botnet. Perhaps, again, this term you've heard before. A botnet happens or is created when hackers or adversaries will distribute worms or viruses online. So sort of perhaps they package them into a download or something you've been emailed. People don't notice anything about worms or anything about this program that's been covertly installed in your machine. It doesn't do anything particular until it's then activated. Bottlenecks it can do. So once you've succumbed to the botnet, once you've been infected with a virus or a Trojan, or something that's attached itself to your machine, and you become an agent or a zombie, sometimes termed as well as zombie, like controlled by the hacker, like being puppeteered, all of a sudden, the adversaries are going to get access to a lot of different devices, like hundreds or thousands or tens of thousands, or even more in some bigger attacks that have actually happened, basically turning all of those computers and rendering them all under the control and being able to direct them and take action in whatever you want. And so in particular, when you take a distributed denial of service attack, all those computers are going to make web requests to the same server, to the same website. And that's the idea, that you have so many of those attacks. So, so many requests. It's really just a question of scale, really, because you're hitting those servers with so many possible web requests. I want to access this. I want to get in the door. I want to access this. Hundreds and hundreds and thousands of all these requests being made at the same time. Just, a computer with physical limits. It can't possibly, the server just can't field all those inquiries that are coming and trying to give those requests the data that they're asking for. Ultimately, that would eventually, after enough time, enough load, result in the server just crashing, throwing its hands in the air and saying, I don't know what to do. I can't possibly deal with all these requests. Sorry, Valentine, I called it a botnet. Something like a pseudo-technical term for just an army of computers. So all being puppeteered by one kind of agency or one collective group of hackers. So that's why most I actually don't know, without saying the word most, but a fair amount of today's viruses aren't particularly destructive. They're just done in a way to amass your participation in their botnet, to take control in a command center, let's say. But by tying it up in this way, the adversaries then damage the infrastructure of the server because they've put so much weight on it that it's essentially denied the service. It's a denial of service attack. If we go back to this, because your mental overload, it's either denied the server, the ability for it to process customers or payments, or it's just taking down the entire website so that there's no information at all. There's no availableness. It's not available anymore for anyone that's willing to look it up. And these attacks are really, really, really common. There's I think there's surveys about this that. So how many businesses are subject to denial of service attacks in a given year? I would say it's about like 20 to 30%. Yeah, so 17 million DDoS attacks, a significant increase. So more and more. Again, these are enough to be disruptive. They're certainly noteworthy. Something to avoid if possible. And cloud computing has kind of made this problem worse in a way. And the reason for that is in the context of AWS and the cloud, your server that's running your business, we know that's not physically located on premises, so it's not our server anymore. We're kind of renting it. It was often the case before that when a business would run the website or they run their own business, they would have a server room, maybe co-location or some carriage that had infrastructure, that had software that was necessary to run the website, to do a home network lab, to run whatever software-based services they provided. So you could run your business out of this in your garage. And that was all local to the business, and no one else could possibly be affected by this. But in a cloud computing context, if we are generally renting one of these now in a sort of co-location facility, we're generally renting out some server space, one of these EC2s, for example, and power from AWS or some other large provider, where it might actually be like 10 or 20 or 50 kind of on this rack, depending on the size of the business and the question here. If multiple businesses are all running the same physical resources, if we're all sharing that server space, such as that if any of those 50, let's say those businesses are targeted by hackers, like let's say the one he's holding is Coca-Cola. Okay, people hate Coca-Cola. Let's all try to perform a denial of service attack on Coca-Cola. That might actually, as collateral damage, take out the other 49 on the same server space. And so, even though we weren't actually part of the attack, but cloud computing is, it's a great thing. It solves a lot of problems. It allows us to scale the website and make it so that we can handle more customers. We can have an auto-scaling group to absorb that excess in capacity. But it takes away the problem of web-based security because we're sort of outsourcing that to the cloud provider. So now it's their responsibility to give it to us. But this does introduce a new problem of if we're all sharing those resources and if any of us gets attacked, then there is a corner case where we lose the ability to access those resources, and use them because someone else might be the target of attack. Yeah, which again might cause organizations to suffer the consequences of a single attack. We know this. It's kind of why we're told to architect with this in mind. The way we would do this is by having I forgot what it was called, cluster placements. So this might come up in a solution architect question. The decision being about how do you want to decide on where your EC2s are placed. If you're going for high performance computing, if you need like very, very low latency peer-to-peer communication, you put them into a cluster placement group, which means that they are physically on the same rack, the same rack space inside of an availability zone. So this person's drawing here kind of illustrates this. They're kind of on the same rack of servers. Spread means in the same AZ, but on different shelves. Partition is in the same availability zone, but it can actually be in different data centers within that same AZ. So a trade-off in performance, high-performance computing, traveling as close to the speed of light as possible versus hedging my bets and putting them out there. Yeah, close together or loose coupling, but actually at a physical level, you do have that option. And or if you want to take a step further and say, I'm still at risk, I'm scared about, if it's a particularly damaging or bad attack, I don't want to be collateral damage. So can I buy my own servers in a way? Can I separate the servers so that I'm the only one using it? Never mind having neighbors above and below me. You can also go for dedicated hosts. Exactly, Anchor, yeah. The idea being that you are renting the room and no one else can use it. Even if you're not there, and Amazon don't like to have empty rooms, they don't like unsold capacity, but you make an agreement with them and say, it doesn't matter if it's turned on or if it's turned off, I'm going to use it for me and me alone. That's one reason why you would go for this. There's other reasons too when it comes to sockets. Often it comes to licenses. So licenses are very, very expensive. Very expensive. Like a typical Microsoft server, let's say 2022 server license will cost you somewhere like £20,000, right? Cost. Oh, okay, I'm way off, but still significant. You would have to pay that per instance. Okay, that would be, well, in this case, 16 CPU, 16 core pack. But if you're looking for something a bit beefier, you can actually share that license across the socket because it's not technically different machines. It's the whole kind of server rack space. So you kind of save money by spending more in a way. There's a trade-off there. It does sometimes come into effect. Again, but this would be something that you have to really look into the cost and kind of weigh them out. So Judy's question about dedicated instance, dedicated host. Good question. Let's before we go off on a quick break. I've never actually looked at the console, so give me a second. Dedicated host, or I know that one is related to basically the server, another is the entire rack space. So if you think about these as AWS, I think they're called 20 units server rack space. What they call an outpost. I just forgot what they're called. So outpost is this idea of you taking it and deploying in your own data center or kind of your own co-location or facility. But the actual rack itself looks like this. This is an EC2. Looking at it, you can also have all these other technologies too, or EBS volumes and the like. So would you like to dedicate? I know it's kind of zoomed out, but if you can get that a little bit closer, dedicated hosts is just one of those pizza boxes. Dedicated instances is one of those units, but the dedicated host is the entire box is yours. So different levels of separation. Again, you have to be a very, very paranoid person to want to completely evacuate your neighbors to say, I don't want to be anyone else's collateral damage. It's very paranoid. Very expensive too. Again, this is something that we don't need to know necessarily because I honestly don't know. If these things do come about, either try to involve a data center expert or get people with data center experience would know how this works. I'm not too familiar to tell you the truth. But to your question, dedicated instance, dedicated versus instance. The host is obviously the most expensive one because you're taking the whole rack for yourself, dedicated, and you can share that license between them. You have per socket visibility into them. But so again, this is why we might try to avoid this. Instances or EC2s that run on hardware dedicated to the account. Okay, they're physically isolated at the host level, so that's from the hypervisor upwards. Even if those accounts are still linked to a simple pair account, okay. But we still might share hardware, so there might still be kind of neighbors above and below us who might not be us, which is why we have dedicated hosts. There's a bit of breakdown here, if I'm honest. That's right, Valentine, yeah. So AWS provides you the instance to where dedicated host, you can choose your own. I don't know to what extent you can say, on that one, pick it from a from a shop, but it'll be yours for good. It'll be one of the ones with a reservation, let's say. I don't think you can. It's not exactly pick and mix, I think. But if you go through the console, let's see what comes up. Huh? What? I'm not okay. I think this might be something I have disabled from the organization upwards. Select instance family, choose a payment method. Doesn't matter. Okay. To cut a long story short, you might still be. Yeah, you can have your license supported across different cores. That's only if you have the whole apartment block yourself, because you have better visibility to that too. Oh, sorry, you like instance type exactly. So yeah, exactly like this. It's like a car, right? I want to have a BMW. Which kind of BMW? Well, I would like an X series or an M series or a Z series, and then I like different models within that family too. Same idea, but there are many ways to cut an onion with with EC2s, and this is just on a kind of on the basis of not wanting to share for collateral damage. Let's say. We're still on the topic where we were about DDoS. So what's the havoc? I mean, what's the downside really to having all this kind of stuff on your computer and the like? Well, beyond just wrecking your own computer, deleting your own files or spamming people or mining Bitcoin and the like, actually what adversaries have become increasingly doing over the years is, creating these botnets, so to speak. That is, it turns out that it's actually much more valuable to an attacker not to completely disable your system because that doesn't really serve them long term, but maybe to install software on your computer or on your phone that's constantly running in the background. And it's not doing anything necessarily bad to you. None of your files are deleted, none of your spam is being sent out, but you are still part of it, you're still infected. And there's some piece of software running in the background. So this hacker has somehow figured out not only just how to infect your computer, but my computer and your computer and your computer and your computer and hundreds and thousands of others in the world, so that if this software is smart enough and it's constantly listening for commands, an attacker can send some kind of commands, not unlike those virtual envelopes to this botnet, and say, okay, computers, all arise at once, and then everyone at the same moment start attacking some server, or everyone at this moment starts sending some emails, or everyone start mining Bitcoin, or whatever it is we're trying to do. And so we can make advantage of this network of computers, or hundreds of thousands of computers all at once, and then having a much more dangerous, powerful attack thereafter. So they quite often take this form of a denial of service attack, or DOS, which is exactly like the name suggests, where the goal is not just to deny service to everyone else, for political reasons or financial reasons or the like. It's one thing for me on my computer, on my laptop, on my phone, to maybe visit. I'm a little bit annoyed at Google today, so I go to google.com and I keep hitting reload and reload. Okay, I go to whatever website. I'll get to Amazon. Reload. Faster. And I'm trying to deny service to other people. But realistically, Google, realistically, Amazon, they have way more resources than I do. So a denial of service attack only really works when if you have a lot of people, a lot of resources yourself, or more resources at least than the attacker you try to visit or attack. Now, hypothetically, a denial of service attack should be pretty easy to stop, but let's just understand some signatures. One of which is a SYN flood. So that's part of the three-way handshake that you establish with TCP. So a host will extend a hand, but fail to grab the hand back and shake it. That's like a kind of a rude exchange. You sort of leave this half open, half, you're greeting someone, but only halfway. So that can, with enough of them, that can saturate the number of available connections to that server that can be made. I love this one. It's called a slow read attack. It's also called a slow Norris attack, if you know the animal. The cute little things. Yeah. Why? Because they're slow. It's like a sloth, whereby you talk really slowly and you don't. It's a perfectly legitimate request, but it's performed by a very slow-moving request. So that just gets in the way. Someone's standing in your door, you can't seem to get past them, okay? Exhausting the server's available connections. Other types of attacks and deliberately malformed data packets deliberately designed to confuse and potentially crash the server's attack. The ping of death being one of them, okay? We'll talk about this more in a bit. These ideas reflected attacks, bombarding a very chatty third-party service or protocol with forged packets, signing your domain as the reply address. Your site will get flooded with responses. Not at all. Good question, Valentine. Are there all layer 7 attacks? If you cast your mind back to this OSI model whereby you have different layers of assembly of rearranging your packets, that actually the first one we just looked at, the SYN flood attack, well, that happens layer 4, for instance, because TCP and IP, that happens layer 3 and layer 4. Layer 7 stuff, application packets are more about malformed packets or like reflected attacks. So absolutely not is the answer. If in AWS, we do have a service to protect against us, to hold this off really. Anyone know what service we can do to reflect, to protect ourselves from DDoS attacks more broadly? Yes, exactly. Shield. So we have Shield. Go back to the Shield's documentation real quick. Great question, Valentine. Does it happen layer 7? Well, yeah, most of it. We actually do subscribe to Shield. Shield Standard by free. For free, we automatically opt in. Shield Standard. Let's talk about that one first. Protects us for layer 3, layer 4, but not often at layer 7. So this is not unlike the difference between a network load balancer and an application load balancer. They're just relating to the different levels of visibility they have into taking packets in. So a DDoS attack is an attack which we've just said, try to flood a target. We try to put enough load on it in order to, to get in the way of other legitimate traffic. The service you mentioned, Shield, just protects us mostly against layer 4s for free, against these ones. So you, by opting in or having an account, really, this gets automatically included. You're not aware of this, but you do. Okay, you have this already for free. But if you would like to buy into this, so let me just retrace. This protects you from most attacks, but not all attacks. That's why there is another, like a freemium and a premium version of Shield. Premium version of Shield Advanced is very expensive. Okay, if anyone does a quick Google search to tell me what the price of Shield Advanced is, I'll throw a cookie your way. So the reason this is much more expensive is because it does come in with another bunch of the feature set is that you also get access to the SRT, the Shield response team. Basically just a bunch of nerds in a building that will help you and hold your hand through an attack. If you've seen Mr. Robot on that first episode of Mr. Robot, where they're kind of panicking and scrambling and they're wondering, why didn't we protect against this? Well, they'll be the people that walk you through that process. It's sort of like an insurance policy. You avoid, you would not like to have your house on fire, but if it does happen, at least there's a payout, at least there's something for that. So Dennis has said, advanced usage, that's $25 for the first gigabytes of regional data. That's transfers between, I think, S3 regional transfers. So data going from one region to another one. I think Valentine's accurate answer. Yeah, $3,000 per month, folks. $3,000 a month. That's the figure I was looking for. Why? Because like I said, it's like insurance. You are likely to, if you have an auto-scaling policy in place, if you are absorbing so much damage that you kind of scale out to accommodate that traffic in order to not lose availability, that is coming from perfectly legitimate requests, then what Shield can do is can waive those costs associated. So that's your insurance. Okay. Yeah, well done. $3,600 a year, dollars a year. So it's not chump change, but for an enterprise that is looking for the top of the very, very next level defense, often enterprises who will probably need this in the first place, need that top layer 7 visibility. So to your question, Valentine, we don't get any for free ourselves, but they do. They subscribe to what they call a WAF rule set. So it's just like those regular expressions we looked at earlier, looking for known threat actors or known bad signatures, and I'll explain that in a minute more. But if without smoke, there's no fire, okay? So if they feel like it's a part of a botnet request, and that, again, is requiring some analysis, it will require some compute, and that is what Shield is doing, it's kind of paying for the compute required in order to analyze your packets coming through, then that's what it is. Yeah, your traffic. Is it good traffic or bad traffic? To layer 4 traffic, IP looks like IP. It doesn't really make that much of a difference. But if you start to read the signatures or read between the lines, which requires, again, more visibility at layer 7 perhaps, that is where you can tell the two apart.
How effective is this Shield? Because in the past, AWS has been breached numerous times, including any cloud provider. I'm just wondering, did they have the shield then? Like, remember when they had I think the Pegasus airline breach in 2022, or did they not have the shield, or was it a lesser, more able version?
I can tell you. So, most of the time we're not hearing about the stories. If it goes well, we probably wouldn't hear it. I don't have it subscribed now, but there's a service called Guard Duty, I think, which would tell you all the kind of port scanning that's going on in your account. If you have an EC2 online with a public IP address, it will get a few requests at it. Okay, just enough time, enough exposure will inevitably have people knocking on the door. Okay, and again, you won't get notified of this if you're not looking into it. Just like news articles won't let the full story go if, again, branding and reputation is part of it. I don't know so much about this one if they are. Well, so what this is a way of getting users infected with. Okay, I don't know, but then infecting you in order to then become part of a spyware. So that's not necessarily part of a bot. It's botnets rather, but not used for DDoS attacks.
Isn't the shield more or less? Isn't the shield more or less the shield, like for all sorts of attack, or is it just specific to DDoS?
Just DDoS. If you're looking for more, this WAF, the Web Application Firewall, which will buy into those rule sets. If I'll talk about them more in a second, actually, but just before we do, they're kind of integrated now together as one. Shield just does DDoS. Malicious web traffic, everything else is WAF. I think they should really just brand it as one thing, if I'm honest. I don't know why there's two different parts to it, but Shield is just DDoS, only DDoS. That's all it does. Whereas WAF is available and everything else. So how does it work? You create a web ACL. Those rule sets either you buy into, managed rule sets. You decide what you want to protect. Let's say, again, the front of my website, an API gateway, a load balancer, perhaps something that is going to be accessible online. So like a platform distribution. I just want to see the next page. Does it let me do that? Nope. Yeah, so here is where I get to decide, well, what do I want to protect? I could define my own with my own regular expressions, more than a bit, but probably what you're going to do is do what is prescribed to you by smart people, researchers and the like, who have put together something like this. Let's take, for example, their own. So protecting us against SQL injection attacks, attack takeover prevention, bot control, and this is the compute required, or 50 compute units, they call it. Okay, there's many other types of managed rule sets, WordPress applications, Windows OS, SQL databases and the like. Okay, the list goes on. These are all taken from OWASP, if you're familiar. These are the common attack vectors out there. So yeah, that's right. SQL injections, we'll talk more of that in a second. I'll give you an example. But yeah, pretty much just DDoS is only the shield. But to answer your question, how effective is it? I don't know, to tell you the truth. I've not been on the receiving side. But I would imagine it's good enough to... In the back of my mind, I remember... There was, this probably will give me information. Yeah, it's on the rise, So this is a case study about a bank has been using it forever. How effective is it? I think this article will probably go into more detail. I remember loosely biggest DDoS attack. This is Andy. A few years ago I said this. Yeah, 2.3 terabits per second was mitigated in 2020, which was previously a DDoS attack on GitHub before that. I don't know about you, but my internet definitely would not be able to withstand that much. But apparently Shield was. It was able to bounce it off. So again, I don't know how to define how effective was it. Did it absorb the damage? Was it able to provide uptime? I think that's the job has been succeeded. That's what it's supposed to do. Can you explain the mitigation process of Shield? So if you are scaling, if you have a DynamoDB table with provision mode, if you have an auto-scaling group that sets a step scaling or without an upper limit, let's say, there's no, how big is your wallet is a question there. There might, case by case basis, they might forgive you, they might understand it, who knows. But if it's something that you are, the bigger you are, the harder you fall, you've got the bigger target on your back. If you are a big company and people will pick at you, then you can have your scaled charges absorbed by, or have your fee waived, in effect. I'm trying to find that information here. Shield. This means you don't pay extra for those standard WAF components when they need to be Shield Advanced. Okay. Again, but that's a question of, am I likely to scale more than $3,000 worth a month? And if so, then that's a question between you and your presumably big company, let's say. I'm not too familiar with this. This is more the enterprise and stuff, to be honest with you, to these fee waivers. That would be through the support staff, to be totally honest with you, or the SRT team, they're called, the Shield response team. I bet they're cool. they will have those answers. I don't know how they actually work. But I'll leave that with you, should that be better. I don't think that's a question that's going to come up very often. Why don't we have a look? So Drew pointed out what a SQL injection attack was. I kind of want to come back to that because we have... Again, so how can we get around this? Well, we said there are some techniques like Shield is obviously one for really stopping them before they're detected. Of course, one of the first things we can do is just firewalling them. A technology by which you might be generally familiar by name, again, mainly a firewall, which actually comes from the real world. So typically in buildings where you have multiple stores side by side, you might literally see a firewall, a fireproof wall that is between two areas or two stores, so that if there's an area like this, a fire in one place or one room, that somehow doesn't propagate over to the next door. Now, in the virtual sense, a firewall is essentially just a bit of software between you and the outside world, whereby, or you and some other network, that keeps data in the network so that you don't want to leave it, and it keeps data out of the network that you don't want coming in. So, for instance, you might be in your own company, your own home, you might have your own internal service, intercom system, or the like, and none of that traffic ideally should end up on the public internet. So you might then want your firewall to block any accidental, intentional attempts to transmit that data outside the network. Conversely, too, if you have a private network at home that you only use for home computing, watching streaming media or the like, and if you are not a server yourself, you certainly don't want random people on the internet trying to connect to your laptops, trying to connect to your desktops, to your watch, to your server, to your phone. You might then want to keep a firewall on your router to keep all the internet traffic out. Now, that said, there are some problems that when you do want to use services where you do want to talk to someone on the outside world, like maybe Zoom or the like, but there are technologies that can help mitigate against this. Firewalls are not necessarily absolute. You can poke holes in them, so to speak. You can allow certain services through. So the idea is that we're only going to allow certain requests from a certain type. We're only going to allow them from, well, not from any IP address, but we're only going to accept them into this port from that place. So remember that TCP/IP gives us the ability to say, well, this service comes in via this port. So HTTP requests will come in via port 80, for example. HTTPS port 443. So imagine a distributed denial of service attack where typically the site would expect to be receiving requests on HTTPS. Well, it generally only uses secured HTTP in order to process whatever request is coming through. Route 53, that's more about the resolving end of the things. Itself also using port 53 for DNS. But if it's kind of expecting that on port 53, if you're expecting to receive a lot of traffic on port 443, I don't think you would set up a server to then become a DNS server necessarily. Route 53 is already a managed service that provides that functionality. But if that was a corner case, if you did want to allow on port 53, for example, then all of a sudden, a distributed denial of service attack would begin because you've allowed that from anyone. It's receiving a lot of requests on port 53 or 80 or whatever. So one way for us to attack this is to put up a blanket between us to tie up the resources and just say, well, actually, I'm not going to accept any more requests on port 80. That might then have a side effect then of certain legitimate users, actual real people trying to get through, I'm closing the door. I don't want anyone through. But what about the real customers that want to come in? Since the vast majority of the traffic I receive on my internet comes in via the front door via port 443, that's just maybe a price to be paid. Okay, that's one technique. Another technique is called sinkholing, and that's exactly what you think it is. So a sinkhole, probably is like a hole in the ground that swallows everything up. And a sinkhole in this context is just a big black hole essentially for data. It's going to swallow up every single request and then not spit them out again. So this would again stop the denial of service attack because it's just taking in all the requests and basically throwing it in the bin, into the void. So it's not going to take down the website or the company being attacked. So that's a good thing. But it's also not going to allow any legitimate traffic from any type coming through, which also might be a bad thing. Again, depending on the length of the attack, maybe, so if it seems like it's going to be a short attack, if you can somehow see that, if maybe the requests start to trickle off and stop because the attackers realize we're not making any progress, we're actually not doing the damage, we're not getting the results that we hope for, perhaps they would maybe give up. So that sinkhole could possibly be stopped and let loose, and then regular traffic could start to flow through again. Basically just a sinkhole that the traffic comes in and throws them in the bin. Another technique that we could use is that of packet analysis. So again, HTTP we know, requests by the web. We know that requests via the web have these things called headers, and they are packaged alongside those HTTP packets. So where the request originated from, the source, the destination, where it's going to. There's a whole bunch of other metadata too. So you'll know, for example, like what browser is that individual using? What operating system are they perhaps using? What is their display window? Are they on a phone? Are they are they sort of in a geographical generalization? Are they in Europe? Are they in South America, and so on? So instead of deciding to restrict traffic via specific ports or restrict all traffic, via the sinkhole, we could still allow the traffic to come in, but inspect it as they come through. So, for example, perhaps most of the traffic on the website we're expecting to come from, just because I said already from South America, and all of a sudden we're experiencing a ton of packets coming from IP addresses that seem to be based, or at least have as part of their packets information that says they're from North Korea, okay, or from somewhere else in the world that we don't expect. We can then decide, after taking a quick look at the packet and analyzing those individual headers, I'm deciding I'm not going to accept any packets from that location. If the ones that match those locations I'm expecting, I'm going to let through, they're fine. And this again might prevent certain customers from coming through, certain legitimate customers who might actually be based in North Korea from getting through. They might actually want to. But in general, it's going to block most of the damaging traffic. So DDoS is really frustrating for companies. It's really slippery because they can do a lot of damage. Usually the resources of the company will eventually, especially if they're cloud-based, and rely on the cloud provider on AWS to help them scale them up, to absorb that damage. Usually the resources of the company are enough to eventually overwhelm the attacker, to stop the attacker, who has usually less resources than AWS does.
Yeah, Marco, I'm just saying most hackers, I'm not one for the record, don't go direct. So what I'm saying, if you're blocking traffic from North Korea, more than likely they're bouncing off other servers in other locations. So how does Shield deal with that?
Because it's very, it would be a very impractical attack if you're actually attacking from your real use. So step one would be to spoof your IP address, pretend to be from someone else. And there are many ways to do this, VPN being the most obvious. And then the question would be I don't really know. At a technical level, there would be more details, but to fingerprint you, essentially saying, if it was you making the same request yesterday and the day before and the day before that and the day before that, and perhaps I'm seeing you log in as a legitimate user, even though you're coming from, let's say like this, I can start to build up a picture around you, say what operating system you're using, what time of day you're sending those requests on, what screen size are you on, what resolution are you on. Is this coming from other things that the HTTP headers would possibly reveal? Again, not a surefire solution. I guess Shield would, it's like a net. It will probably, it will try to capture as much as it can, but a lot of it will come through. And with the information that HTTP headers can give off, they can start to build up a picture about you. So how does Shield, AWS Shield, fingerprints, HTTP headers? Let's see if I can find some information online. So the ability to inspect and utilize headers information for security purposes. Okay, so stand corrected, maybe that's not true. It does definitely happen with WAF, I know that much. Okay, so that's one way around this. Again, this idea of transport layer security to encrypt a packet, that part of the three-way handshake, so the hello, the acknowledgement, and then the acknowledgement of the acknowledgement, as I think Chantal pointed out earlier, that's what we call the kind of SYN-ACK. Part of that can be used to identify you. You can create your own custom rules. That's not really what I was looking for, though. Actually, work. I don't know. Is the short and long of it? Like I know the product, but I don't know how it actually works. How it's able to tell you apart.
I think if the same IP as well is seen in different locations randomly, it's acknowledged as being like spoofing.
But you won't know if I'm a hacker and I'm spreading my attack from different systems out, like WhatsApp or Comedian, you get different IPs, like thousands of. So I'm just wondering, how do you shield? I mean, there must be some fingerprints that go in the background to looking at the type of message. I'm just wondering how does it figure out that, okay, this guy is a hacker, even if he's not coming, which is not going to be coming from North Korea or Russia.
Right, but with the DDoS and the IP, say the IP spoofing, it's a fake IP address. So if you've got an IP address, one day it's in Africa, the next day it's in England, or just the rate of it, then it's going to flag up as suspicious. So that's how they identify, especially with the bots, when they take over different bots and it spreads. It's just suspicious activity.
What you can very simply do is with the use of an IP address spoof, so you could become someone else, you can impersonate another address, even at home. I mean, think about how many other people could use your Wi-Fi network, supposedly. You yourself, other family members too. How can you tell those two apart? It's not enough to just rely on one IP address, because that's not enough to tell us the full story. Instead of relying on these other techniques, which I'm really struggling to find a way of pinpointing an actual technical answer for you. I know it says it protects us, but I'm trying to find out why or how.
Yeah, I'm having a dig too, but I can't see anything. It's just very high level stuff. Almost as if they don't want us to know how you don't. Because the hackers read these manuals also. You know,
I know this too. So capture is the one obvious one, but you can do that too in WAF, by the way. So, so earlier I was saying, I feel like you're not. If I'd like to capture this information, I'd like to stop it before it hits my my downstream service. I could send a managed rule group. One of them is actually a capture. I think one of these was a capture. If I can scan out, but this is all still part of part of bot control. So how can protect us against this? Additional visibility through CloudWatch, generates labels that you use to control bot traffic to applications. Learn more. This is still on WAF. To be honest, I'm not able to find a deep technical answer on how Shield protects it. But at least for WAF, it is. Inspect the labels, recursive tokens, client session tracking verification. This is what I'm trying to find out. How does it do it? Okay, so that's the fingerprint I was getting at. It's a collection of information about a single client. The client stores provides every web request sent. So with high probability, because it's the same. Let's imagine that there's 10 people at home and 9 of you are using iPhones and you're the one person using Android. Well, even though it seems to all come from the same, your router's public IP address, there are some of those packets within that give off other metadata, like actually it's coming from this particular operating system, actually it's being displayed on this particular resolution on the screen size. Those other things are able to fingerprint you, to build up a story that is with high likelihood a particular person or a particular device. And if that particular device is part of the botnet, then we can discard those ones whilst allowing the other 9 remaining family members through. We could also challenge them, say, prove it, although that's also deteriorating in effect. By the way, you've seen this. I mean, I know you've come across these. What do you call them? Oh my God, Cloudflare. Have you ever seen Cloudflare before you visit a website? Pop up on screen.
No, but I remember a few years ago they leaked some non-IP address for the internet into the internet and caused a lot of problem.
You've never seen something like this before? You just had to click a button?
Yeah, I've seen that. Yeah, I've seen that.
Well, that's it. That's DDoS protection right there. You could verify that you're human, and Cloudflare is a DDoS protection service that provides that. It's just another company that does that.
Have you played about with Kiro yet, Marco?
I haven't. How's that? KIRO?
Yeah, it's the new AWS IDE.
Oh, yeah.
And you can hook it up with different MCPs. There's one that you can hook up that bypasses is it CAPTCHA? Is that how you say it? But there's an MCP you can hook up with Kiro, which bypasses captcha.
So it's not kind of a telling. Okay, so Kiro is this new and improved Code Whisperer instead. They've just rebranded it, remade it. It's their kind of push to get Q into the minds of developers and use their own SDKs. It may very well also be able to prove captchas right. That what is a captcha, by the way? It's a completely automated public Turing test to tell humans and computers apart. It's an acronym. Yeah, that's it. To tell computers and humans apart. So we know Alan Turing, great English computer scientist, came up with the Turing test in order to know if AI was at the point where it could deceive a person, if you didn't know whether you were talking to a machine or not. Nowadays, I think we've well exceeded that point where like, just talking on chat-based computers are really, really telling. They have optical character recognition that could possibly tell this. There are many types of captchas. Some of them, not all of them, rely on OCR, on optical character recognition. So, for example, this one here, it's kind of the training data set isn't at the point where it can make out some of the weird shapes and kind of the motifs around these letters and characters. So there's a lot of squiggles online. AI doesn't know anything, it recognizes patterns. If these patterns don't exist on the training data, it ain't working it. There's also audio-based captchas too, but most of the time it's not this. I think we only see this when it actually has to prove, well, we have to challenge us. We're at the last leg of, are you real or not? I actually can't tell. Most of the time, when you press that button, it's relying on, again, the fingerprint of, do we suspect anything from you? Are you a suspicious user? The way that you click that button, like the way that you move your mouse, is it completely angular? Is it then, like a robot moves? Is it like as the crows flies? Was it more la-di-da? Is it more human in the way that you approach that button and click on it? The response time of the like, there are the signatures that can possibly be telling of that. I can prove it right now. Let's go on to this image and capture example. Most of the time, this is just being used. I mean, why do you think we see a lot of roadside or like vehicular type of captures? Take a wild guess why we see these above all else. So if this is supposedly meant to deceive a computer, right? Let's go to, I was going to come to this, but I don't think we've quite got the time, but what is this? What's in here? Yeah, let's be as nondescript as possible. Well, it clearly knows. So I'm not, this isn't fooling anyone. It appears to be a street intersection with a traffic light system. I can see this, I can see that, I can see a better response than a human could give. Okay, so clearly it's not that a computer can clearly say this. But why do you think it's, of all things, is it helpful to have this in the training data? Why isn't often vehicles on the roads? Why not, can you tell apart an apple from a banana? Can you tell the sky from the sea? Why is it that maybe this is more useful to ask humans? Folks, if you haven't realized already, you are part of the biggest experiment ever. You're part of supervised training learning. Supervised learning. It's how Cloudflare make their money back. They require high quality label data, which the initial problem with machine learning is, well, how can you tell X from Y? How can you tell those two things apart? It's all brought down to probabilities, really. But it really helps if you have a data set of high quality training data, one that has previously been labeled. That's the difference between supervised versus unsupervised learning, is that supervised learning has been supervised by a human, by a person. So that's one that does require us to, hey, that's a car, hey, that's a bike, that's a bridge, that's a thing. So we're training the machines. Yeah, we're adding more high quality training data to it, let's say, because self-driving cars are the future and AI recognition and lorries and that's going to be the next big market. So that's when it's more trying to piggyback off of us. But the actual classic captures, the ones that are still possibly harder, I don't know, let's try. It might actually be at the point now where it's good enough. Because if you ever use something like, what was it called? What am I thinking of? What's it called? The machine learning.
Bedrock?
SageMaker?
Not SageMaker, the one that can read. The one that can look perform OCR.
TextRact?
Yes, thank you. TextRact. Because it extracts the text. So can it work? Is the question. If you upload this. So this is a pretty clean document, clearly it's able to pick apart tables and formulas. Let's upload our own. Yeah, go for it. Give me everything you can see. Is it that it's too small? What's the problem? What? I think it's too blurry is the problem. Let me find another one.
Smaller than 5 megabytes? Is it more than 5 megabytes, or is it the right type of file format?
The file format's fine. It's the actual resolution. Let's have a look. I think it wanted it to be smaller, so definitely smaller.
PDF or what is it at the bottom there?
Larger than 400 by 400, so it's got to be those dimensions. It's just that was pretty small screenshot of a already small picture. Let's take maybe this one. It's too small. Oh, let's just do it. Go for a big one. Large. Okay, perfect. The most roundabout way to get it. Okay, we got it. So let's go back to this. I'm seeing, can it? Yeah, I mean, that's fine. I've seen worse. Have you ever done those audio ones where it'll play different instruments? And they have to say, oh, that's a piano, that's a horrible, really. it jars me. I've walked away from them before. I cannot stand it.
I think I struggle to tell the difference between a violin and a piccolo, to be honest.
It's like, which of these has melody? I can't remember what it is exactly, but in a way that one is clearly human and the others are not meant to be music, because apparently they can't tell. If you hear AI generated music, that, I mean, to be honest, everything's come a long way. Everything is pretty good now, but early recognition, early results were terrible. Come on, this is such a faff to get to what I wanted to. That was, sorry, this is far more than I actually wanted to. That's why, because I'm in the wrong bit. I'm so sorry. This is a much more roundabout way of getting to what I wanted to do. I don't want to do that. I just want to give one document, please. Please. There you go. Just do that one. What's wrong? I can't understand. Okay, so I can't make sense of it, but I'm sure that it would probably work now. But the long story short is that captures are one thing, but they're not the be-all and end-all. They're a puzzle, but puzzles are breakable. We're just trying to raise the bar for the adversary and also not make it so hard that we ourselves can't. But with anything, you're going to find people that will find a way around this. I can't give you a firm answer on how Shield is able to cast a net and decide what to let through. I'm struggling to find that answer myself. But what I can do, and there's not too much time, but I was hoping to do a quick example with you. Let me do a really quick example of how we can perform something like cross-site scripting. So this is something that you could, we've got this idea of server-side and maybe client-side code. Client-side code, remember, that's something that runs locally on your machine, on your browsers, for example. It's expected then to interpret and execute that code. Server-side code is run on the server. So when you get information from a server, we're not getting back the actual lines of code, we're getting back the outputs of that code being run on the first place in the server. So for example, there might be some code on a server, some Python code or some whatever code that generates some HTML for us. Now that actual Python or that actual PHP or whatever it is would actually be server-side code. We don't actually ever see that code. We only see the output of that. So cross-site script vulnerabilities exist when an adversary is able to trick your browser into running something locally. And it will do something that presumably the client, didn't actually intend it to do. This is a bit, okay, just to look at an example of what might be a very simple web server called Flask. Again, so this is some Python code. Again, don't be worried if this doesn't make sense to you. It's pretty short. It's just a simple web server. It does two things. So this is some boilerplate stuff in Flask. Okay, so Flask is a package of Python that's used to create web servers. The web server has two things that it does. The first is that whenever I visit this /roots on my web server, so let's imagine that this is my website. If I go to market.com, which you may actually not explicitly type, but most browsers will just add a /, which just means go to the home page, go to the roots page of your server. So if so, call the following function, whose name just happens to be index in this case, return hello world. And so what that basically means is if I go to market.com /, what I receive back from the server is a HTML page whose content is just hello world. So again, this is all server-side code. You don't actually see this code. You only see the output of it, which is HTML, okay? A simple string in this example. But it would be interpreted by the browser as HTML. However, if I get a 404, and a 404 is a not found error, it means that the page I requested for doesn't exist. And since I've only defined the behavior for literally one page only, the / of my server there, then I would want to call this function not found, return not found plus whatever page I tried to visit after that, whatever the request path was. So it basically is just a very simple web page, much like hello world again, where instead of saying hello world, it's just not found. And so then it concatenates that onto the very end of that, whatever the page tried to visit, okay? So this is what we call a cross-site, well, it's a vulnerability, and to explain why. So let's imagine I go to /foo. So if I'm trying to get to, again, market.com, web.com, and /foo. So we call that our error handler function from earlier, which I've just put down here again, will return not found /foo. Seems pretty reasonable. It seems like the behavior that I would have expected or intended to have happened. But what if I go to a page like this one? So this is literally what I type into the browser, market.com, but not /foo anymore, but / script, open tag, script, close tag, parenthesis, hi, open, close, well, this, this string there. And this script looks a lot like HTML. In fact, that's what the browser will see. That will interpret that as HTML. And so I will get returned by visiting this page, not found. And then, so I'll get not found plus everything here, okay, except for the leading slash, which means that when I receive this on my side and my client, my computer, my browser is interpreting this as HTML, I'm going to generate an alert. What's an alert? Well, if you've ever gone to a website and you've had a pop-up box, display some information, you've had to click OK or like X just to make it go away, then that's what alert is on JavaScript. So when I visit this web page, I've actually tricked my browser into giving me a JavaScript alert, or I've tricked whoever visits my page into giving some alert, okay? It's probably not a good thing, but I can get a bit more nefarious than that because, so imagine instead, like instead of it having to be my server, it might be easy to imagine it like this. So this is actually what I wrote. The script tag here, this is what I wrote into my social media profile, for example. So you know how Twitter, Facebook, whatever, they give you the ability to write a short little bio about yourself. Let's imagine that bio was this. Okay, it was script, document.write. And then I have this hacky URL and then everything. So I can imagine that I own hacky URL. That's my website. So I own hacky URL and I wrote this inside of my profile. And so assuming that Twitter and Facebook and Google don't defend against cross-site scripting attacks, which they do, by the way, but assuming that they didn't, anytime anyone ever visited their profile, their browser would be forced to contend with this script tag here. Your browser would have to look at it. Why? Because you're trying to visit my profile page. You're trying to, if you're landing on my page and if you're rendering the page information, my profile page literally contains these characters inside of them. And these are going to be characters recognized and interpreted as HTML. And that HTML is telling the browser to add document.write. And then this is a very JavaScript way of saying, add the following lines in addition to the HTML of the page. Image source equals hacky URL, cookie plus document.cookie. So again, imagine that I control hacky URL. That's my website. Presumably, I'm running the website, so I also maintain logs of it if someone tries to access my website. So what page they're trying to visit. If someone goes to my profile and executes this, then I'm going to get notified via this hacky URL that someone has tried to go to that page, cookie equals, and then document.cookie. Now, document.cookie in this case, because this exists on my profile, again, that's an individual's cookie for Facebook, for Google, for whatever. So what I'm doing here is, again, like websites would defend against this nowadays. It is very recognized. So this can't actually happen in reality, but assuming that they didn't, okay, what I'm basically doing is I'm getting told via my log that someone tried to visit some page or my URL, but the page that they're trying to visit, I'm plugging in and I'm basically stealing that cookie that they tried to use for that website. And a cookie, remember, is like a hand stamp. It's basically me, instead of me having to re-authenticate, re-log into the page every single time I want to use it, I'm going up to the website and saying, hey, remember, that's my hand stamp. You've already verified my identity. Just have a look at this and you get let in. And so now hypothetically, I know someone else's cookie. And if I was clever, I could actually try to use someone else's cookie, and then I try to change what my cookie is to that other, swap them out. And so I'm suddenly able to impersonate someone else, and I'm able to log in to their profile and back to them. So that's all happening via this image tag, which is really just a clever trick here, because the idea is that I'm trying to pull some resource from my site. It doesn't exist. Now, this resource isn't real, but it's like a window to a thing. And that thing, I don't have a list of all the cookies on the website, but I'm just being told now that someone is trying to access the URL on my site. But the idea is that I would be able to steal someone else's cookie where that attack is not well defended against. So what can we do to protect ourselves? To an idea of earlier, it turns out that we can sanitize. There are HTML entities, which are basically just other ways of representing certain characteristics in HTML that might be considered special or control characters. So things like open and close brackets, for example. One way for me to prevent that from being interpreted as a script is to call this or to call this something else other than the left angle bracket, other than the right angle bracket. So swap it out for something else. And it turns out then that these little HTML entities can be used to refer to these characters instead, such as that if I were to sanitize my input in such a way that every time someone literally typed out the character left angle bracket, I had them written some code to the right that automatically took this and changed it into something else like ampersand left and greater than. And so that basically every time that someone wrote the character less than or greater than, or left angle or right angle bracket, that would actually be changed in the code to this or that. And then that way the page was basically responsible for processing or interpreting something, but it wouldn't interpret those potentially dangerous characters. It would still just display the characters as left angle bracket, right angle bracket. That's what the greater than or less than stands for there. But it would literally just show those characters and not treat them as HTML. Let's actually just do a quick example. Just before, I know time-wise, maybe I'll save that for another week, but I'll kind of demo this in front of you. But back to this website. Let's just finish up this one. Back to the denial service. Try writing an IP address to block the traffic from attackers while allowing HTTP access for valid users. Well, again, one of our tools was a firewall. Harmful traffic detected. Enter a net mask, so that's this thing here, to block traffic from these known bad actors or two private address ranges. So let's stop 10.8.0.10. Okay, firewall, that's blocked. We also need to block this one. I'm just going to save myself from writing it all out, although it probably would have been quicker. Yeah, it doesn't work. 10.0.8.10. 10.0. There you go. Okay, so that's one way of blocking this, but of course, it's not a very effective solution. If, to your point earlier, you can spoof an IP address, you can just impersonate someone else. It's like a phone box. If you're doing dodgy deals on a phone box, you could be in one phone box one moment and then another disposable phone box the next, or like a burner phone. So it's not really helpful just to pinpoint those ones. To overcome this defense, we've invented a distributed denial service, a network of bots, a botnet, to orchestrate a massive wave of requests. And there's many examples of that too. Okay. Oh, okay. So some ways we can protect against this: serving images, caching would one way around this. A lot of caching. Timeouts, try to break up the job into asynchronous parts to basically synchronize the time factor, automate the website deployment. Yeah, so I think I sent this link before, so maybe that's more use of you if you're trying to find out actual protections against them. I just wanted to finish on the notes of cross-site scripting. Okay, maybe next week I'll go through an example of what this actually does and how this looks like. But if we took, for example, we're the owner of Reddit.com, bit on the nose, the number one social media for all the baking industry, you have an avid community of commentators who love sharing the bread knowledge. So on Reddit.com, roll it says, okay, so comments from other users. Because the main use of your website is to facilitate discussion, users can add comments which are saved to the database to for users. It's a forum. Unfortunately, the popularity of your site, again, the bigger target on your back, has also attracted the unwanted attention of hackers. And unless you are careful when constructing the HTML, hackers can also abuse the comment function by injecting JavaScript. So watch how Mal, that's this bad actor here on the right, injects some, okay, that's my alert function before, like this. So literally an alert function has been rendered on my page because my browser, has treated or interpreted this HTML as a JavaScript function. So open, close bracket, so script, alert, your croissants are limp and sad. Can you see how that's appeared on my browser? I've got this annoying pop-up I need to swat away. So again, not truly disruptive by itself, but again, indicative of the manipulation that can be done. Okay, so a real attack might use injected JavaScript to not only just alert you or display something to the screen, which is maybe not that dangerous, other than just scaring you, but it can also do things like stealing documents, stealing cookies, or other cross-site forgery requests. How can we do this? Like I was saying, you could swap out one for another using these regular expressions, escaping dynamic content, like I said. So rather than using open bracket, close angle bracket, you can actually substitute that character for another one. Okay, that's what I was just getting at here. But that's all going to happen if you've done your research and you've opted in for WAF-based rules. Well, that's what it does. Okay, I might do a whole session on WAF because it's such a big topic. But if you go back to Web Application Firewall, to the console, I now realize I've closed off annoyingly because I got frustrated with this is my example I was going to share with you. This is, by the way, a completely fake website, one that I've built myself. But the idea is that I can type in anything. Log doesn't go anywhere because it's not a real website, but it appears like a form field that is truly itself. And that information, I'll show you next week how it works. But it would be captured by this little text file right there. Oh no, sorry, I would have to run the program first. Open terminal. Okay, so now I've got the Flask development. Okay, that's now active. If I return back to that website, so this is my HTML here. I'll demonstrate much more next week how this works. So what's my name? My name is Andre the Giant. And is my path. Whatever, okay. Oh no, it didn't go through. Only that if I go through my captured file, I believe. Where did I store it? There you go. Oh no. I completely forgot. I'll figure it out for next week, but I'll do I'll show you how that can be done. It was one that I was trying to fight Claude to build for me earlier, but it said I couldn't because that's known for being a bad, it's against its own guardrails. But I'll get around it by next week, okay? Sorry, I'm just catching up with the chat now. Does it come with a 500 code as well? I'm sorry, what was that question in relation to, Valentine? The 500 code? So server-side code, server-side messages?
I asked the question when you were talking about the what's it called? Yeah.
Oh, sure. I mean, these status codes are whatever I want it to be. This is one that like a user-defined function. But if I'm looking for any 500 status codes, that's going to be usually the sign of a like you can set these things up with an API gateway if you wanted to get into it. But
That's good.
Yeah, it's going to be anything. I mean, there are some which are known not by the application itself, but by your browser. So my browser tried to resolve this. I said, I can't. It's not working. If I looked into the page source, it would probably come back with a particular status code somewhere. I don't know where it is probably found, but somewhere in here, these are things that are known less by the server itself or more by the browser. So yes, is the answer. Like either being timed out or it being unable to resolve or some other problem.
Thank you.
Yeah. All right. Yeah, I'm looking at the time, folks. Sorry, I went off the trails again. I need to do that.
Oh my goodness, it's 10:15.
We've got lives to attend to and cats to feed and like truly a big thank you. Very valuable. I'm glad to hear it. These are again things that we can only really get around to, not because it appears on the architecting course, but that's what these sessions are for. If you got something out of it, then I'm all the better for it. Salute. See you soon.